cylindrical wire of copper, then you may know about all these charges. So there are so many positive and negative charges. And I've explained you how it comes. There is a nuclear force of attraction between the electrons and the atoms. Suppose if the outermost electrons or the valence electrons absorbs energy, then where it goes, it may goes to its higher excited state. That is higher energy level. So that there the force of attraction is reduced. The nuclear force of attraction is somehow reduced, and then it may, yeah. Am I audible? Okay. And then we can say that what is that nuclear force of attraction is reduced means it can act individually as an electric charge, as a negative charge. Okay. So this copper 2 plus ion is act as a individual positive charge. But even then these two have influence, right? So one among the other is influenced too. So it is in controlled motion, we can say. So these charges are now static charges. So static charges are in controlled motion. Now, what will happen if I've told you no? So this is a copper atom. So fourth orbit. So it's a nucleus. It's nucleus. And then here the electrons. From the fourth orbit to the 11th orbit, it goes, for example, after attaining high energy. Caleb, are you there?
Yes, ma'am.
So it goes to 11th orbit. For example, I'm saying it is not compulsion. So it's an example. So after attaining this 11th orbit, it can't able to, it is now acted as individual since the distance is very higher. Okay. Then after that, what will happen? Again, it achieves this particular electron, it achieves some velocity. So that is known as drift velocity. Since you know that the electrons are revolving around the nucleus in various orbits, right? Right or not? So it is moving so that it has its own, so how the energy shells are coming, it has its own kinetic energy. Since it is moving, it is definitely, associated with the velocity. So that Bohr's postulates discussed all these things. We got to learn atomic structure and chemistry, very, very important lesson. You don't think chemistry and physics are various fields, even if it is various fields, vast field, but there is a link between these two. Okay, you have to understand. So what is proper atomic structure? So that is very important. Now it is drift velocity. It is attaining its drift velocity. That means it is drifted. Since it is moving, it has to, the electron has to revolve in its orbit, right? Okay, around the nucleus, it has to move. Suppose if the electron is undergoing some drift velocity, it may not be able to move in its path. It may escape from the orbit. Now it escapes from the orbit. Now these electrons are said to be free electrons. Can you able to understand? What is it now?
Yes.
What is it now? It is free electrons.
Free electrons.
So these free electrons are moving randomly in a metal only. I'm talking about in a metal, not elsewhere, in a metal only. Okay, so inside the metal, now these free electrons are freely move elsewhere, so that due to the motion of this free electrons, the current is produced. What is the current definition you have learned from your childhood days? Or we can say, and from 5th standard onwards, you have learned, right? What is current? You have learned about the flow of charges. Right. You simply learn flow of charges. Or in higher classes, last year and all, you can know current is the flow of free electrons. Now you come to the point, how the free electrons are produced in an atom. Is it clear for you? Is it clear properly? I have narrated as a beautiful story to you, all these things. Clear? So, this is an atomic structure. You have to just admit that God has created in the sense these atoms also obeying the law. Okay, understood? Okay, so now what will happen? So this is said to be the free electrons. This free electrons moves randomly inside the metal. Okay, and then it produces its, I mean, you talk about, so the scientist perception, you should think in scientist perception. Okay, if the electrons are revolving around the nucleus, then it is having its own energy, right? That is kinetic energy, you said. So that is said to be the electrical energy or electrical power or electric field. The scientist gave that name. Okay, if the electrons drifted, okay, or it is drifted from its orbit, so it attained its own velocity, that is drift velocity, then it becomes a free electrons. Since the electrons are free, it is vigorously moved when compared to its orbital motion. Okay, initially it was an orbital motion. Now it is very free to move elsewhere randomly. Okay, or it may have collide. So it is a possible, there is a possibility to collide with this positively charged ion. Now this positively charged ion is fixed. It is not moving. Get my point? Hello? Okay. So now the free electrons are moving inside the material, and then it may hit the positively charged ion, which is fixed, and then it may collide, right? So that it experiences lot of energy. That energy is named by current by the scientist. That's all. Okay. So each and every energy associated with an atomic motion or electronic motion, it is taken as an energy into a practical application. Now we are using this current, and then it is made into device. See how bright our scientists are, right? So all these ideas and wisdom given by our God, right? Awesome, super colossal God. This is very, very important. Okay, then what I'm trying to say, this drift velocity is said to be the free electrons with when it attains. So now the current comes. So what is the current? Now we can come to the conclusion. The current is designated by letter I. Okay, so the current is designated by letter I. So there is a difference between electric field and the current. Electric field stands by the orbital motion of an electron. Get it? Get my point? So electric field is, we can talk about the positive charge and the negative charge. So static charges. There is a field around the positive charge. There is a field around the negative charge. This and all you have studied already. Electric field. So the electric field is inwards for the positive charge. Do you remember that? The electric field is outwards for the negative charge. So this and all you have studied. Suppose you say about the unlike charges attract each other. Like charges repel each other. Everything you have learned, right?
Yes, ma'am.
So this is the electric field lines or the lines of force, we can say, right? Electric field lines you have learned. So from the positive, it moves outwards. For the negative, towards the negative, it will be. From positive to negative. Okay? It is inwards to negative. Like this. Okay? Understood? Like this, you have drawn. Do you remember with this?
Yes, ma'am.
So this is electric field lines. So it is an orbit. It talks about the orbital motion of an electron. That is, we come to know static charges. These are all the charges. Now the charge become the free electrons. That is, the free electrons are coming out. So that produces current. Due to the flow of free electrons, the current is there. So current is designated by a letter I. And then we can simply give some definitions, some derivations to the current. What is current? Q by T. The amount of charges or small amount of charges. Okay? dq by dt also we can write, or q by t also we can write. For an enclosed area, if you are considering an area, you can say q by t. If it is continuously infinitely long straight conductor, it should be taken as dq by dt, for example. Okay, so this q by t is nothing but the amount of charges flowing per second. Okay, so that is current. Understood? How many amount of charges flowing per second is taken as a current, and then it is defined by a unit by ampere. So ampere defined as unit. So its unit is ampere, or we can say the charges, the unit of charge is joule, time is second. So joule per second, or coulomb per, coulomb per second. The charges are measured in coulombs. So coulomb per second. So this is coulomb. Clear? Coulomb per second or ampere. So this is the unit, SI unit for current. Ampere. Clear? Get. And then I've told you, no, the charges and all. So that and all represents the cells, right? And then there is a direct current and alternating current. Both are explained in this. See here, electric current. So what is DC is explained here. Okay, in your book. You know about the clear idea about current, right? Okay, so that is the basic idea. Now we will get into the syllabus. What is here given? Electric current. What is an electric current? Okay, you know about the cells, okay, and everything. So the cells are the source of direct current. For example, it provides current to the bulb to glow. Okay, so it should contain definitely, what is the battery? It should contain definitely positive and negative. Positive electrode and the negative electrode. You know, right? Positive
Yes,
and negative. So this and all you know, right? You can just read through and just know about it more. Okay, so some definitions also given. Okay, so why this brass cap is made on? Okay, so how it is acting? Everything like a GK it is given. Okay, can you go through it?
yes, ma'am.
Okay. Then there are two types of cells, primary cell and the secondary cell. Primary cells means these cells provides current as a result of irreversible chemical reaction. So the cell means it is operated in a chemical solutions. That is electrolytic solutions are present. That means it is the aqueous solution we can able to know. So aqueous means it is converted into an ions. Suppose if there is sulfuric acid solution. Okay, in the sulfuric acid, H2 plus and SO4 2 minus. It's split up into positive and negative ions. Clear? Clear. Split into positive and negative ions. H2O is split into positive and negative ions. Like this. These are all said to be aqueous. It's not solid, or it is not gas, or it is not liquid. So it is splitted into aqueous. So this is used as an electrolytic solutions. Then what will happen? This negatively charged ion attracted towards anode or cathode. Negatively charged ion.
Negatively charged. Positive.
Attracted towards anode, right?
Yes.
Then possibly charged attracted towards cathode. So by the movement of the charges, the current is produced. So that is known as, electrochemical process. So during electrochemical process, the current is produced. So it is chemical energy now converted into electrical energy. Clear? So the primary cells are used up with a irreversible chemical reaction. These cannot be reversed. That means a liquid becomes ions, right? That is aqueous. It won't turn up into liquid again. Clear? This is irreversible. So primary cells are irreversible chemical reaction. What about the secondary cells? Here in your book it is given. Secondary cells also provide current as a result of chemical reaction. Here the chemical reaction is reversible. So you can consider again and again the reaction takes place. So there is more and more electrical energies are there. That means current is produced again and again. Clear? Clear or not? So there are two different cells of this kind, that is direct current. It produces current by means of irreversible chemical reactions or reversible chemical reactions. Okay. So these are always known as accumulators. So it is accumulate current again and again. Secondary cells are. Okay. So this is a differentiation between these two. You just better go through it. And then I've told you, it is the rate of flow of electric charges. That is the amount of charges flowing per second. Both are same. What is rate of? Rate of means 1 by time. Get my point? This and all I've explained you. Right or not? Hello? Okay. But this current is a scalar quantity. It is not a vector quantity. It is a scalar quantity. Okay? Then what is the SI unit of current? We know. And then you must understand this Q they are taking, right? This is very important point. You'll be asked so many questions based on that. Always the charges are quantized. Make a note of this in your notebook. Charges are quantized. Okay, always.
What does that mean?
Always charges are quantized means, can you able to take one positive charge outside, or if you want to observe something, what is happening in it, if you want to measure the current, can you lift up one charge from it? It is impossible. You can take an amount of charge. For example, 1 centimeter of wire only we can able to take, or half a centimeter of wire. So it talks about the amount of charges. Now the charge is said to be quantized. Okay. So an amount of charge, a packet of charge, or we can say it is quantum. So now we can always see in quantum mechanical manner, not in a classical manner. Classical manner deals with the single particle, single electron, corpuscular theory, all Newton's theory of corpuscles, corpuscular theory. So after Einstein and the Planck, the quantum theory enters. So we need to talk about in quantum level. So that means we are taking everything as a packet, quanta of energy, okay, quanta. Now the charge also said to be quantized. So how it is said to be quantized? The energy, the equation or expression is Q is equal to N times E, where N is the number of charges, E is the charge of an electron. Since we are talking about only free electrons here. In static charges also, the charges are quantized. There you can take either protons or not, we can say protons, it is a positively charged ion. You can take positively charged ion or you can take negative charge. In static charges, if you take the quantization of energy in static charges, Q is equal to Ne, this E represents positive charge or negative charge. So the charge of an electron by J.J. Thomson experiment you have learned, right? About the history of atomic structure. So J.J. Thomson discovered, he found experimentally the value that is 1.6 times 10 power minus 19 coulomb. This you might have studied last year, this value.
Yes.
1.6 times 10 power minus 19 coulomb. So for positive charge, it will be plus. For negative charge, it will be minus. That's all. That's all the difference. If there are, suppose 9 positive charge of copper, there might be 18 negative charge of copper. Because one copper lose 2 electrons. Clear or not? So 1:2 like. Okay. So if you want to find the quantization of that particular charges, Q is equal to, what is the amount of charge I said? 9 for positive charge. 9 into 1.6 times 10 power minus 19. For negative charge, you can take Q is equal to negative 18 times 1.6 times 10 power minus 19. Clear? So likewise, you have to find the quantized charges. But here there is no other go, only the electrons. Free electrons are responsible. So N times E will be the quantization of charges. Can you able to understand all these things?
Yes.
So it is discussed here. What I have discussed you with, so that is discussed here. So the number of electrons can be, the total current can be written like this. Okay, that means it says about positive charge of N1. Okay, there are N1 number of positive charges. There are N2 number of negative charges. Clear? So this is the total current. Understood? What I have explained you, that is given as here. Okay. Then direction of current, it is very, very important, the direction of current. So suppose if the flow of electrons are like this, electrons means negatively charged particle. Suppose if the wire is connected with, okay, the battery, this is positively charged, positive terminal, this is negative terminal for a battery. Okay. Now the electrons flows from positive to negative or negative to positive?
Is it positive to negative?
Positive to negative? Electrons. Negative to positive, right? Like this.
Okay, yes, sorry.
This is the electron direction. Now, conventional direction of current is in its opposite way. Positive to negative only, the conventional current direction is. Okay, ma? Okay. So, always opposite to the direction of an electron. That is discussed in this point. See? The rate of flow of electrons in a direction is called the electronic current in that direction. So conventional current or simply current is in a direction opposite to the direction of motion of electrons. Can you able to understand?
Yes, ma'am.
So I've told you this SI unit and everything. You just go through it. This and all you know. You know about milli and micro, right? You know the
Yes,
scale, exponential form. Okay. Then there are sources of current which is given as I've told you, no, direct current is there, alternate current is there. So alternating current, I'll explain you about. So how the alternating current will be. So the vibration, or we can say the sinusoidal, the current as a sinusoidal waveform, like this. Okay, both positive, negative, positive, negative, positive, negative, positive, negative. Like that, the alternating current will be. Alternate, maximum, minimum. Okay. If it is a direct current, only maximum might be there or only minimum might be there. Clear? Hello? So most of the devices are functioning in direct current. We are getting alternating current from our, EB post or something. So direct current is now converted. I mean that AC current is now converted by DC current by all devices. For example, if the refrigerator is running means it is converting the AC current into DC current. There is a converter inside all the devices. Because alternating current means if it functions in an alternating current means, suppose if there are fluctuations happening, then definitely the devices won't be working proper, or it may just burn due to that extra, I mean, more power, more current. Okay. See, for example, all AC currents from the main. So we are having all our houses are having main supply. The main supply is AC current. Okay. The devices and the switches which we are having inside our home. So that is converting that AC into DC current. So that is safe current. You can go through it. Then there is AC generator. Okay. Direct current, everything it is given. Okay. Okay. Just go through it. So what all explained by me, it is given. So these are all the symbols. You can go through it. Okay, all the symbols, right? Can you go through the symbol? Rheostat means it is a variable resistor. That's all. You can just adjust this arm. here and here by vary the resistor. Okay. There is a resistivity of a wire. So in order to find the voltage, you can use this voltmeter. In order to find the current, you can use this ammeter. You know about the potential energy, potential or potential difference. So all the potential difference is carried as a voltage. That also you have learned, it seems, last year. That means the charges, the work done, okay, work done in moving unit positive charge, because you know the unit positive charge is very heavy. What is the mass of a proton and mass of an electron comparatively?
Electron is negligible.
Very negligible. That is exactly, I must say, mass of a proton is equal to 1837 times mass of an electron. So approximately we can say 2000 times greater than the mass of an electron. Mass of a proton is. Since copper atom we talk about, right? So copper 2 plus. In copper 2 plus, how many number of electrons present? In copper 2 plus. Out of 29, 2 last.
20.
27. There are 27 electrons with it and 29 protons with it. Right or not?
Yes.
This copper 2 plus contains 29 protons. It's very heavy. It can't move easily. It is fixed. It is fixed in a wire in its material. So that must be, it requires some force, okay, or some electromotive force is there. The work done in moving, what is the work done? Force times displacement is the work done, right? What is work done? Force times displacement. Okay, so this electromotive force helps this particular positively unit positive charge to move from one place to another place. So this is recorded as potential difference. The work done in moving, you can write this point in your notebook. The work done in moving, unit positive charge. The work done in moving unit positive charge from one place to another place is known as potential difference. Clear? So it is registered as a voltage. Potential difference is nothing but it is a voltage. It is measured by voltmeter in volts. It is measured by voltmeter in volts. So these are all the symbols of a cell, battery, AC source, and everything. I told you, no, the AC will be like this. Maximum minimum. So the AC symbol is like this. Just go through it. So key is needed. Key is very important in a circuit. If you close the key, then the circuit works. If you open the key, the circuit breaks. Okay, there are different kinds of keys. Just go through it. Then resistance wire, resistors, everything it is discussed here. I will explain you about this resistors in the next class. Until then, okay, you can go through it. This resistors and then voltmeter, connecting wire, everything it is given here. Simple electric circuit also given here. Until this closed and open circuit. Until this you can go through. 9A. Finish this
Okay.
9A. 9A. And then I have told you about potential difference. We'll discuss it again. Okay, so finish this until 9A and then do submit. Take it as a homework.
Okay.
Okay. Bye-bye.
Thank you. Bye bye.